Welcome back to the reef, everybody. So if you remember from last time, we headed out into the water with our snorkel gear to look at two different coral reef ecosystems with Trisha, Ed, and their science team. Now remember, we're trying to figure out if there's a difference in the number of herbivorous fish between what we think is an unhealthy area, area number 1, and what looks like a healthy area, area number 2. So we went out and collected information in both locations. We laid down quadrat squares in both areas so we could figure out how much of each reef was covered in algae. That way we could check and see if there really was a difference in reef health between the two areas. We also took video so we could count the number of fish that swam in front of us. That way we could measure the difference in the number of fish between each area. And then finally at each sample spot we measured water temperature. Working outdoors in nature, you never know what kind of weather you're going to get, and it looks like a pretty big rainstorm is heading our way right now. So it's a good time to change out of our wetsuit into some dry clothes and head back to the lab with Trisha and Ed where we can count up all of our data. Now back in the lab, Trisha, Ed, and their science team will look at pictures of the quadrats or the sample squares that they laid down while they were out on the reef. You can see that Ed is looking at a picture of one of the quadrats right here. And it's kind of hard to tell how much of that quadrat or sample square is actually covered in algae. So this larger square is divided up into smaller squares to make it easier to count. We decide whether each square is mostly coral or mostly algae. There are a couple of different types of algae in this picture. So to keep it simple, we'll just count the squares that have the larger green algae, like you can see here. And we need to do this for each sample spot we measured. Next, we need to turn that number into a percent. To do this, we simply multiply each number by 4. This is because each quadrat has 25 squares inside it. 25 times 4 equals 100%. So the number of squares times 4 equals the percent of the quadrat that's covered in algae. In this case, 40%. Next, the team is going to download all of the video they took while they were out at the reef, and they'll simply count how many fish they saw. The team will also write down the water temperature and distance to nearest pollution source at each sample spot. Now, after Trisha, Ed, and their crew have gone through and collected the information they needed from each sample spot, it's time to do some math and make some graphs. We're going to start by taking some averages for each sample spot. Now, that may sound kind of confusing, but it's actually very simple. Let's look at the fish count for Area 1 as an example. First, we add up the number of fish counted at each sample spot in Area number 1. The total in this example is 15. Next, we divide that by the number of sample spots. In our case, we had 5 sample spots, so we divide by 5. That's how you find the average number of fish found in Area number 1. Now we'll go ahead and do this for each set of information collected in each area. So now that we've calculated our averages, we can draw a few graphs, and this is going to help us look at our results side by side. This really lets us see actually whether there's a difference between Area 1 and Area 2. And we're going to start off once again with our fish example. This is a bar chart. On the left part of the x-axis, the line going across the bottom, we have Area number 1. And on the right, we have Area number 2. At each hash mark on the y-axis, the line going up and down, represents the average number of fish counted in each area. Using the numbers we just calculated, we're going to fill these bars in. Now here's the average number of fish we found in Area number 1. And here is the average number of fish we found in Area number 2. The bigger the bar, the more fish in the area. Can you tell which area had more fish? So now we'll make bar charts for the other information we collected. That way we can easily compare. Let's take a look at what our team came up with. We can see in Area 1 that a greater percentage of the reef was covered in algae than in Area 2. Now this suggests that Area number 1 is actually unhealthier than Area 2. We can also see that Area number 1 had fewer fish than Area number 2. So there aren't as many fish in area number 1 to eat the algae and prevent the algae from taking over and killing the reef. Now, this is a clue or a piece of evidence that our hypothesis might be correct. But what about the other pieces of information we collected? Remember, coral needs all sorts of different resources to live, grow, and be healthy. So for example, if one of our coral reefs had a higher water temperature than the other one, or if that coral reef was closer to a source of pollution, that could also cause the reef to become unhealthy. Now let's take a look at what our scientists came up with for that one. When we look at our results, we can see that water temperature was almost exactly the same in area number 1 as it was in area number 2. We can also see that both areas were just about the same distance away from a source of pollution, and that the source of pollution was actually pretty far away. Now this is another clue. No difference in these other resources between the two areas means that they probably aren't the reason area number 1 is unhealthy. Area number 2 is totally healthy, and it had the same water temperature, and it was the same distance away from a pollution source. However, the big difference in the number of fish between the unhealthy and healthy area is a hint that there may not be enough herbivorous fish in area number 1 to eat the algae and keep the reef clean. Now keep in mind, this only gives us a hint about what might be happening in this one small area. If we were to find another coral reef, either in the Great Barrier Reef or in another coral reef ecosystem somewhere else around the world that we thought was unhealthy, we'd have to design a study, just like we did here, to try and figure out why.